Welcome back to another video, everybody. Today we're in a Pontiac and we're gonna be doing some tuning, but not any kind of tuning. Today we're gonna be talking about fuel additives, specifically octane boosters. And I'm not gonna be talking about whether you should get them and whether you shouldn't. We're just gonna look at the data and we're gonna see, do they work? Let's find out. So let's talk a little bit about my car. We have here a 2009 Pontiac G6 with about 183,000 miles on the clock. If there's any car that needs it, it's most likely this one. It has carbon buildup on the cylinders. I'm almost certain of it because I get unbelievable amounts of knock on lower octane fuel. I can show logs, I can show all this and that, and 85 octane here at this high altitude location is the worst for this car. I have to retard it by about, I don't know, 6 or 7 degrees of timing just to get there to be a small amount of knock. And so I think that this is the perfect car to test this on, because these are what this product is advertised for, is cars like this. Cars that are older and it says restores gas mileage, restores power, all this and that. So let's find out if it works. Without further ado, let's get logging. So I've got 85 octane in this car right now with no fuel additives added to it. So we're gonna head to Walmart and we're going to go and get some octane booster. We're gonna get 2 bottles. First, what we're gonna do is we're gonna add 1 bottle to this fuel, and then I'm gonna add 91 octane to this fuel, to the tank, and then add and do another test, and then we're gonna add the other bottle to it. We'll have 4 data points to look at. Regular 85, 85 with the octane booster, and then 91 and 91 with the octane booster. So, without further ado, let's get going. Except it's never that simple, is it? So, as soon as I started logging, I realized I had the tables messed up. I had the high octane and the low octane were separate tables, which to test this, I wanted it to just only rely on one table. So I knew that it wasn't switching over to high octane as soon as I put in higher octane. So I messed up the first part of the logging. And then once I moved on, I decided I was just gonna keep it all on high octane and see if we could lower the knock from 85 to 90, 85 with the booster to 91 without the booster, and then try 91 with the booster. So that's where the video continues. All right, so we're gonna do the same thing as what we did before, but instead this time we're just gonna copy the high octane to the low octane so that no matter what, it will be running this. The high octane is about 4 degrees more advanced than the low octane, and we're gonna save this as a high octane testing table. All right, so that didn't go as planned, as you can probably tell, but we're gonna go ahead and switch over, as I've shown you before, to the high octane table that I was using before, that it was referencing. And to get clean data, I went ahead and copied the high octane to the low octane, so no matter what, it's gonna reference this high octane. And we're gonna see with the octane booster and 85 octane fuel, we're gonna see if it shows any knock, and if it shows similar knock or different knock, and then we will go back and later I will add 85 octane to the gas. And so we're gonna go ahead and start and redo all of that. We're gonna go back to Walmart from the other side of town. Maybe, hopefully not get pulled over, but we'll see, and we will. So immediately looking at the table, and this is because it's low RPM side of it, immediately looking at the table, I already see tons of knock. So we're definitely gonna have to retry this test with the 85 octane fuel by itself, but to see if there's any real difference. But just looking at it already, like, man, I'm getting tons of knock, and it doesn't look any better. All right, so right as I expected, there is really a ton of knock from this 85 octane fuel. And this 85, I believe I got from Walmart. So we are stopped here at Walmart again, and now we're gonna get 91. And just looking at the table here, I mean, man, it is rough, especially in the high mid RPM range, but high air mass range, so the high throttle areas. Man, there is like up to 4 degrees, 5 degrees of knock retard. And man, that is almost maxing out the maximum retard that is allowed in the ECU. So that is really bad. So we're gonna drive around for a little bit, hopefully get the fuel to mix a little better, and then, you know, we will see what we can do. We'll see what it starts looking like, but initially it's gonna be about the same as just before. I ran it right to about empty. And so it should be mostly 91 octane that's left in there. So we'll see what we get from the knock. Right now we're still getting some knock because it's probably still at 85, but I feel like after about maybe 5 minutes of driving, we should see an improvement. I'm gonna go ahead and get on the highway, see if we can get some of this fuel just out of this system. All right, everybody. So we are in the middle of nowhere by the looks of it, but after doing a lot of highway pulls, street pulls, and just general trying to hit the boxes and such, I have noticed there is a lot less knock in 91 octane than there is in 85, even 85 with the booster of the tank. So we're going to add the rest of the octane booster, do some more logs, and compare the two. I am pretty confident that this octane booster does not replace high octane fuel in the slightest, but it may actually help with a little bit of knock. All right, so we have finished our logging. We have gone around, down, we've done some highway pulls, some street pulls, and man, am I surprised at the results. And I'm also not surprised. So let's go home and let's take a closer look at the different tables and the knock retard that's been happening. Okay, all right, now that we're back in the house, we're gonna take a look at the different log files and show you the differences between them. Right now I have loaded up, let's go log folder. So I have a whole bunch of different ones. Let's start with the 85 octane no booster because that shows the roughly a mixture of the two spark tables, but it should show mostly the higher octane, but it will show a mixture of the two. So as you can see right off the bat with 85 octane, we're getting a bit of knock, about 3 degrees, and the higher RPM, higher throttle pulls. If we open up, now this is the high spark table 85 with booster. So this is with the octane booster, and you can see, man, there is knock all across the board. You can see we're getting up to 45 degrees of timing roughly, and we are getting a ton of knock. Down here, we're getting around 23, 24 advance, and it's getting retarded back down to about 20. We're getting a lot of retard on here. Now, I would assume that now we're gonna have to go back and we're gonna have to take a look at um, when we put in 85 octane without booster and see with the same exact advanced table on both the high octane and low octane, see if we can get them the same and see if the results are any different. We ought to just redo the whole test, but what is useful is the second we move to 91 octane with no booster. So I'm gonna go ahead and omit the table where I did some polls here with the 91 and 85, and right in the beginning I started going and it was getting a lot of knock, but then it immediately started going down. And so once it kind of evened out, I assumed that it had mixed mostly with the 91 already. So
This is the 91 without any booster. We have a lot of data. You can see there is not very much knock at all, but here in the low RPM and low mid-range throttle area, we have a tiny amount of knock. And I'm curious to see if that goes away or if it stays about the same in the other one. So let's go ahead and take a look at this. Let's go ahead and make this smaller. Make this big. All right, so looking at the high octane with the with the higher spark octable and the booster, we can already see that there looks to be less knock. And this could be attributed to the fact that there's less 85 being mixed into the mix. Um, and this is why I'm saying I really ought to just redo the whole test. This is not really showing much, but we look at the no booster, and you can see in the lower RPM, uh, mid-range throttle areas, there's a lot of spark. But we go back over here to the with the booster. Let's go ahead and take a snapshot of this, and you can see this is the old, this is the new. We're getting around, let's say 1.6, around 0.28. There is a little bit of knock in this area, and I wish I got more of this area, but it looks to be about the same. Maybe a little bit less, but not enough evidence to show that it is working or not. Could just be the fact that there was indeed less um, fuel, less higher octane fuel that was being mixed into the mix. Or it could just be that there was less of the lower octane fuel into that mix. And as we had expended more of that lower octane fuel and got more just general higher octane, we start getting these lower numbers. But I did add about 6 ounces of the 5 or 6 ounces of that octane booster to about 5.5, maybe 6 gallons of fuel in my tank. And so that could have attributed to some of it. But by the looks of it, I don't see much of evidence that there is much of a difference.
So I'm sorry if that video is a little disappointing. We didn't get very clear results. I'm gonna do some more testing. We're gonna get some more logs. We are gonna upload some more videos, and we're gonna see really if this stuff actually works. Because I like this idea where if we put some data behind this, maybe it shows whether they're bullcrap or not. And my scenario is different than everyone's. I'm in higher altitude area, and there's different, I mean, the 85 fuel here is just terrible. So this is kind of an extreme case with the higher mileage engine and such. But hopefully we can get some more testing done, and hopefully we can really compare the two. But I will upload all the files to this to my GitHub or to a repository so that you guys can download these and you can look at them yourself if you're curious.